All right, let's go over trends on the periodic table. So things that we observe, things that we see, observations that you can kind of look through on the periodic table. So first one, these are the three that we've gone over already, but the three trends on the periodic table, first is trend in atomic radius. And so we need to figure out what is atomic radius. Well, atomic radius is the size of an atom as determined by the boundaries of its valence electrons. So one of the key things here, it says valence electrons. Valence electrons are the outermost layer of electrons, or you would consider the s and p orbitals of the electrons. And so that's just the size. So if you were to draw a dot right in the middle of the atom, center of the nucleus, and go all the way out to the furthest electron, that would be your atomic radius. And so what is the trend that we observe? Well, in looking at this periodic table, we can kind of see the biggest element on the periodic table is the bottom left, and the smallest element is the top right. And so it's interesting, as you go down on the periodic table, it makes sense because you're gaining shells of electrons, you're gaining electrons, it gets larger and larger. However, going from left to right, it gets smaller. So that's kind of an interesting idea where you're adding protons, you're adding electrons, even though you add electrons, it's getting smaller. So we'll talk about why that's the case. So largest found in the bottom left, they have a large number of rows or shells of electrons, and then so the largest is not the right side, which has more protons, more electrons. And this is the idea of shielding. So shielding, what is that? In essence, you have your nucleus in the center of the atom, and you have these electrons that are kind of in the closer to the nucleus. And those electrons are repelling that electrons that are further out. And so in essence, as you add more and more electrons, those electrons are being kind of repelled from each other, and they're moving further away from the nucleus. And so that's kind of like holding, as you get further and further away from the nucleus, more and more shells, they are more repelled by each other, and they are farther away from the nucleus. But this doesn't really describe the fact that the right side of the periodic table has the smallest elements, and that is because as you go from left to right, you also gain protons. And so when you gain protons, there's more of that electrostatic attraction from the electrons to protons. And so if you're looking at, like, let's say potassium, which is K, calcium gets smaller, so you add a proton, so that addition of proton is attracting those electrons more, holding it closer. As you go down this, you can kind of see it gets smaller and smaller and smaller. Even though you're adding electrons, you're also adding protons, and that addition of protons is holding the nucleus together, and it's holding the electrons closer to itself. So even though krypton, which has 36 protons, 36 electrons, is even a smaller atom than potassium that only has 19 protons, 19 electrons. And so that the main thing that is determining the size is the electrons. So the potassium, which has 19 electrons, is significantly larger than the krypton, which has 36 electrons. So that's just one trend. Another trend that we see is about ionization energy. And so we got to figure out what is ionization energy. So this kind of once again brings us back to the idea of the valence electron. Ionization energy is energy required to remove a valence electron. And so how much energy is required? Let's kind of see what the trend is here. So the largest towards the top right corner, and that is because atoms hold on to the valence electrons the tightest. And then another idea of kind of shielding here. So shielding you can kind of think of as you have electrons closer to the nucleus which are blocking other electrons and kind of shielding them from the attraction of the nucleus. And so if we're looking at this, the smallest numbers that you'll see are the bottom left, and then the largest numbers you'll see are the top right. And so in essence, if you're looking at this, helium is one of the most difficult elements to remove an electron from. It would take 2,370 kilojoules per mole just to remove one of its valence electrons. And so if you're thinking of that, helium is a small atom. It has 2 protons, 2 neutrons, and 2 electrons, typically. And so when it has those 2 electrons, it's really held on tight by those protons. and so it's really difficult to move that away. As you get further and further away from the nucleus, you add more and more shells. Those electrons become further and further away from the nucleus and are easier to remove. So, like if you're looking at this very first family, hydrogen, lithium, sodium, potassium, rubidium, cesium, francium, all those elements have one valence electron, and so that at the outermost shell, they have one electron, and so it's most easy to remove that electron, so its ionization energy is lowest. And so once again, ionization energy is the energy required to remove an electron. Another trend is the idea of electronegativity, and so electronegativity is the tendency for an atom to pull electrons, and that's going to be very similar to the electron affinity, which is the energy required or energy released when an atom kind of attracts an electron. So in the same way, it's the same trend where electronegativity is the ability to attract an electron. So if I'm looking at this, electronegativity is the ability to attract an electron. The highest values are going to be the most attractive. And so if you're looking, there's a bunch of numbers on this periodic table. There are no numbers for the noble gases, which is that very right side family. You'll notice that all these elements have full valence shells, so they're not going to be attracting electrons in any way. And then you have the lowest numbers on the bottom left, highest numbers on the top right, not including the noble gases. So electronegativity is the tendency to pull electrons, and so it would look like fluorine would have the strongest pull of electrons. And so if you were to think a fluorine would have 7 valence electrons, it could use one more, so it's really going to attract, really going to pull an electron. It's going to be the strongest pull on the periodic table. And so kind of just to overall summarize those trends, once again, as you go down and to the left, the atomic radius increases, with the bottom left element, which is francium, being one of the largest elements on the periodic table, and the top right, helium, being the smallest. The overall trend that you see in ionization energy would be as you go to the left to the right, it increases, and as you go from the bottom to the top, it increases. That is ionization energy. And last trend is the electronegativity, which you can kind of substitute for the idea of electron affinity, and most favorable towards the top right part of the periodic table, such as that. So not including the noble gases. But hopefully that was helpful in kind of summarizing the trends of the periodic table, and let me know if you have any questions.